Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be starting Section 5 of Chapter 1, Solving Inequalities in One Variable. Solving inequalities is going to be very similar to solving equations, except we have to do something called graphing our answer at the end. And there's one extra thing we need to look for and consider when we solve inequalities. So let's take a look at some examples to see how these mathematical problems work. Before we get straight into the example, I would like to discuss the 4 different types of inequality symbols that we will come across as we solve inequalities. The first symbol is greater than. Greater than is a symbol that points to the right. It kind of looks like a rightward arrow. And I remember that that means greater than because right has an R in it. Less than is like an arrow that points to the left. I remember that's less than because it points to the left and less has an L. And then we have 2 other symbols that are kind of similar to these, except they have a line underneath. So we have less than or equal to pointing to the left with a line underneath. And then we have greater than or equal to, an arrow that points to the right with a line underneath. It's very important that you can differentiate between these 4 symbols and tell me what they are when you read an equation. So you want to make sure you're practicing that, and we'll get a little bit more about them as we do the examples. Now, one last thing before we get right into those examples is depending on the symbol is how we're going to graph our answer. So if you take a look, greater than and less than, for those problems we use what's called an open circle. So when we get our answer on a number line, we literally place an open circle at that number. Whereas if it has a line underneath, meaning greater than or equal or less than or equal, we use what's called a closed circle. So we're actually going to darken in that circle when we graph because that means that our answer is included. It was equal to. So we need to differentiate between an open circle and closed circle as well. And again, we're about to do some examples so we can see this in play. So our first example says 2x plus 1 is greater than negative 3. So when we solve inequalities, what we're going to do is we're going to draw a line down the inequality symbol, just like we did with the equals, and we're going to solve these just like we did a regular equation. So first thing I'm going to do is get the variable part by itself. So I'm going to subtract 1 on both sides. So I'm going to have 2x, and I'm going to have negative 4. And then I'm going to divide by 2 on both sides. So if I divide by 2, I'm left with x, and negative 4 divided by 2 is negative 2. And then I'm going to drop down my inequality symbol. So I have here x is greater than negative 2. Now, the way that this is different than an equation is an equation gave us a single number as our answer. This is saying that any number greater than negative 2 is our answer. So the second thing we have to do with inequalities is graph our solution. So you'll see over here to the right, I have a number line. What we're going to do is we're just going to kind of create a number line. I'm going to put 0 in the middle. I'm going to count up to 5. I'm going to count backwards. Negative 3, negative 4, negative 5. So I'm going to count backwards to negative 5. And what we're going to do when we graph, first we take a look at our inequality symbol. This is greater than. When it's just greater than or less than, that means our answer is actually not a solution. So we use what's called an open circle. So at negative 2, I'm going to put an open circle. And then this says any number greater than negative 2. So I want to think, is negative 3 greater or is negative 1 greater? Well, negative 1 is greater, so what I'm going to do is I'm going to shade from that circle all the way to the end of my number line. And that's saying that any number that falls to the right of -2 is a solution. So these types of problems are twofold. You first have to solve the inequality to get the inequality statement, and then you have to graph to have a picture to go with the inequality statement. All right, the second example is x over 6 minus 2 is greater than or equal to 10. So for this problem, what we first want to do is we want to draw a line down the inequality symbol, and then we're going to solve this like we would a regular equation. So I'm first going to get the fraction x over 6 by itself. So I need to get rid of minus 2 by adding 2 to both sides. So this is going to give us the fraction x over 6 and 12. Now I want to get x by itself, so I need to think what's happening with x and 6. Well, they are being divided, so I need to multiply by 6 on both sides. When I do that, on the left, the 6 is canceled, so I have x, and 12 times 6 is 72. At this point, I want to drop down the inequality symbol. So I'm going to bring down the greater than or equal to. So this is telling me my inequality statement is x is greater than or equal to 72. That's the first part of our answer. The next thing we need to do is graph our solution. So to graph our solution, I first need to set up my number line. Now when I have large numbers like 72, I'm actually going to set up the number line to include those large numbers. So say maybe I will start at 70. So I will put 70 in the center, and then I'll count up on the right and the left until my number line is complete. So using this number line from 65 to 75, I'm going to graph my inequality statement. X is greater than or equal to 72. Now, anytime our inequality symbol has that line underneath, it means or equal to. That means that the number we got is a solution to the inequality. So anytime you have that line underneath, the or equal to, we have to use what's called a closed circle to graph it. So when I use a closed circle, I'm going to go to where 72 is, and I'm going to darken in a circle at 72. That's what's called a closed circle when I fill it in. And then I need to shade in the direction that it says. This says any number that's larger than 72. So if I think which one's larger than 72, 71, or 73, it's 73. So I'm going to shade towards the right arrow. And then my graph is complete. So again, two-part answer here. First is our inequality statement. X is greater than or equal to 72. And then is our graph with the closed circle shaded towards the right. The next item to discuss about inequalities is called the golden rule of inequalities. The golden rule of inequalities says, when multiplying or dividing by a negative number, we must flip the inequality symbol. It is very important that we pay attention to this rule when solving inequalities. We have to know what number are we multiplying or dividing on both sides of the equation. If it is a negative number, then we have to change a greater than sign to less than, and vice versa. So when we flip the inequality symbol, that's what it's talking about. Greater than would now become less than. So let's take a look at some of those examples. 6 is less than or equal to 13 minus 7y. So I'm going to start by drawing a line down my inequality symbol and solving this like a normal equation. So the first thing I would need to do is to get the negative 7y by itself. So I'm going to have to subtract 13 on both sides because right now it's a positive 13. So 6 minus 13 is negative 7. On the other side, I still have negative 7y. Now, to get y by itself, I need to divide both sides by negative 7. So negative 7 divided by negative 7 is positive 1. We're left with a y. Now, since I just divided by a negative number, I chose to divide both sides by -7. The golden rule of inequality says we must flip the inequality symbol. So right now it says less than or equal to. I need to flip this to be greater than or equal to because I divided by a negative on both sides. So my inequality statement says 1 is greater than or equal to y. So 1 is bigger or equal to any other number is my inequality statement. Using this statement, we now need to graph the solution. So I'm going to start with 0 in the center because this is kind of small, and then count up on both the right and the left to complete the number line. Now, using the inequality statement, it says 1 is greater than or equal to y. I'm going to go to where 1 is, and I'm going to put a closed circle at 1 because my inequality symbol is greater than or equal to. That means 1 is a solution. And then I need to shade in the direction so that 1 is bigger than the numbers I'm shading, because it says 1 is greater than y. So I need to think, is 1 bigger than 2 or is 1 bigger than 0? Well, 1 is bigger than 0, so I need to shade this to the left to go with the inequality statement. So always make sure you're using that statement as your guide for which way to shade. 1 bigger than the numbers, 1's bigger than what is to the left of it. So that would be the second part to our answer. -3y minus 8 is greater than 22. Again, I'm going to start this problem by drawing a line down my inequality symbol and then solving this like I would a normal equation. So I would first get -3y by itself. So I'm going to add 8 to both sides to get that -3y is by itself, and 22 plus 8 is 30. Then I'm going to divide both sides by -3. So I'm going to have y, and 30 divided by -3 is -10. Now, since I divided by a -3 on both sides, the golden rule says anytime you multiply or divide by a negative number on both sides, you must flip the inequality symbol. So when I drop down greater than, it's now going to be less than. So this says y is less than -10. So that's the first part. We have our inequality statement. The second part, I now need to graph this. So -10, I'm actually going to choose just to start with that number because it's a nice clean number. Usually if it ends in 0 or 5, I'll start there on my number line. And then I need to finish the left and right sides by counting up and down. So that will be the next thing. So using my completed number line, what I'm going to do is graph the inequality statement. Y is less than -10. So first I need to put a circle at -10. So I'm going to go to my number line at -10, put a circle. I'm going to use an open circle because this says less than. That means -10 is not a solution. We need anything less than -10. So an open circle, and then I need to shade towards the numbers that are less than -10. So would that be towards -11 or -9? Well, -11 is smaller, so I'm going to shade this to the left. And that tells me anything going to the left of -10 is a solution to this inequality. So again, we have our two answers, the inequality statement and then our graph to go with that inequality statement. This concludes our lesson on section 5, solving inequalities with one variable. If you have any questions, please ask Miss Brooks. Otherwise, I'll catch you next time on your Daily Dose of Math with Miss Brooks.